Good evening. Are you hear me? So this is the okay. Thank you, Sharnavu. So today I'm going to discuss first properties of the correlation coefficient. Good evening, Shashwat. Properties of correlation coefficient. Okay. So I already discussed correlation coefficient R is Sxy by root over Sx square Sy square, where Sxy is a covariance between two variables x and y, which is defined as 1 by n sum over I from 1 to n xi minus x bar. X bar is a sample mean of x bar is a mean of y x yi minus y bar, and ss x square is a variance of x, which is sum over I from 1 to n xi minus x bar whole square sy square, which is equal to 1 by n sum over I from 1 to n yi minus y bar whole square. Okay, we knew this thing from our previous class. So the first property of the correlation coefficient is, yes, Shashwat, happy independence to you, sir, all of you. So property 1, correlation coefficient of any two variables is a pure number. We already show that R is independent of, it is a unit free measurement. So R is unit free measurement. So the correlation coefficient of any two variables is a pure number. That is independent of the units of measurements of the variables. And this is follows from the definition. It is also is symmetry. That means correlation coefficient xy of the variable x and y is symmetric in x and y. that is Rxy equal to Ryx. See, Sxy and Syx same. Similarly, Rxy, this is Rxy, okay? And Ryx is Syx by root over Sx square Sy square. So these two are same thing because Sxy equal to Syx. So that's why correlation coefficient is symmetry. The numerical value of correlation coefficient is independent of the change of origins and scale of the variables. That is, we have n pairs of values xi, yi, I from 1 to small n of the variables x and y. Now introduce two new variables u and v, where u equal to x minus a by c, v equal to y minus b by d, where a, b, c, d are arbitrary constant and c not equal to 0, d not equal to 0. Then corresponding to each pair of values xi, yi of xy, we have a pair of values ui vi of uv, where ui equal to xi minus a by b by c and vi equal to yi minus b by d. I from 1 to small. This implies xi equal to a plus cui for all I 1 to n, then x bar equal to a plus cui. Therefore, xi minus x bar, which is equal to cui minus ui. Similarly, yi minus y bar, this is equal to d into vi minus v bar, I from 1 to small n. Thus, variance of x, which we denote by capital Sx square, which is equal to 1 by n sum over I from 1 to n small capital Xi minus or small xi minus small x bar whole square, which is, if you replace xi minus x bar by c into ui minus u bar, then you get c square 1 by n sum over I from 1 to small n ui minus u bar whole square, and this is simply c square into variance of u. Similarly, yes, Shashwat, you are right. One is shorthand way to represent 1 to n. Yes, actually, this is 1 to n means, Shashwat, are you here? Hear me? Please see. 1 to n. This means within bracket 1. This means difference. So this is 1, 2 difference. Common difference is, this is a common difference. 1, 2, 3 dot 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 small n. If you take a common difference 2, then it should be 1, 3, 5, so on up to n. Okay, so this represent the common difference, and 1 is a starting value, n is a starting ending value. If 2 is a starting value and common difference is 1, n, this means this is 2, 3 up to n. Okay, so this is the way we can represent 1 dot dot 1 2 dot up to n, 1 3, any numbers which are in arithmetic progression. Okay, this is the process we can represent. Are you get it or not? Shashwata, please respond. Shashwata, are you hear me? I am waiting for you. If you have a still problem, please tell me. I will again explain this thing. Okay, thank you. So similarly, variance of y, which is equal to b square variance of v. Covariance between x and y, which is 1 by n sum over I from 1 to small n xi minus x bar yi minus y bar, which is equal to c into d 1 by n sum over I from 1 to n ui minus u bar vi minus v bar. Okay, so Rxy, correlation coefficient between xy, which is covariance between xy by root over variance of x into variance of y. So covariance of xy, which is c into d, this is nothing but this portion is nothing but a covariance of u comma v. So covariance of xy is c into d so of u comma v by root over c square variance of u into d square variance of v, and this is equal to cd mod of c. This is the absolute value. Mod means absolute value, that is mod of 2 is 2, again mod of minus 2 is 2. This takes only magnitude, not consider the sign. Okay, I think you knew this thing. By into covariance of u comma v by root over variance of u variance of v. So this is nothing but a Rxy, which is equal to cd by mod c mod d into this is ruv. So you observe that Rxy equal to cd by mod c into mod d into ruv, which is ruv if u and v are, sorry, not u and v, this is c and d. C and D are both are of same sign, are of same sign, and this is minus RUV if C and D are of the opposite side. So we observe that after change of sign, location and origin, the magnitude of the correlation coefficient of two new variables are same, but sign may change depending on the sign of C and D. Clear? Clear? Have you any queries? Please tell me. Again, I repeat this thing, after changing the new variables, correlation coefficient, magnitude of the correlation coefficient are same, but the sign of the correlation coefficient may change depend on the sign of C and D. Okay? So, please tell me, have you any trouble? So sometimes we, for computing correlation coefficient, we use transformation of variable, because after transformation the computational process is easy. Okay, so that's why we use transformation of the variables. So for example, Orko Provo, thank you. For example, suppose we have two paired observations, suppose 2.52 2.49, 2.47, 2.42, 1.69, 3.43, 4.72, and Y is 5.50, 6.10, 7.30, 8.70, 550, okay, 610, this is 730, 870, 880, 930, this is 400. So we observe that for computing correlation coefficient of between x and y is quite laborious, because see the if you look at the observation, you can easily see that the covariance of xy, if you find the covariance of xy and variance of x and y, is quite laborious. So for reducing the labor, we can transform this two variables x y to new variable u, where u equal to, we already defined u equal to x minus c by d. Okay, so generally we consider c as a x bar, which is a mean of x, and the mean of x here is, if we compute this thing, which is 2.82, and you can take suitable c here. So c you may take 7. So if you use this transformation, then you see that your u is like that, minus 30, minus 33, minus 35, minus 40, minus 113, 61, 190. And similarly, if you consider this transformation for the variable v, that is y minus y bar by 10, then you get minus 16, minus 10, 2, 16, 17, 22, minus 30. Now, you can easily compute correlation coefficient between u and v. Why? First, you see that u bar, the sum of this observation is 0. So u bar should be 0. V bar, again the sum of this observation is 0. V bar also 0. So covariance of u comma v, this is nothing but a 1 by n. N is 1, 2, 3, 4, 5, 6, 7. So here I use 7 paired observations. So 1 by 7 ui vi, because u bar and v bar both 0. So this is equal to minus 6369 by 7. Okay. Similarly, you can compute variance of u's, which is again 1 by 7 sum over ui square, because u bar equal to 0, and variance of v, which is equal to 1 by 7 sum over vi square, because v bar equal to 0, and then you get RUV, which is equal to minus 0.548. Okay, so please check this calculation, but we are interested in Rxy, and according this property, The magnitude of Rxy is the same as magnitude of RUV. So it should be 0.548, and sign depending on the sign of this, that is our C and D, so depending on the sign of C and D. Here C is 7, which is positive, and D is also positive, that is 10. So sign of RUV here and the sign of XY are same. So that is, so for that reason, the correlation between XY should be minus 0.548. Okay. So that is the beauty. If you use this transformation, you can easily compute the correlation coefficient of whole variable using this property. Okay. So sorry. So have you any problem? Shayok Prabhu Shashwata, please tell me, have you got it? Have you get it or not? Can I go to the next property? This is property 4. I think you can understand this thing. Okay, I go to the next property 4. Okay, so correlation coefficient always lies between -1 to +1. So if the correlation coefficient goes to either +1 or -1, this means this indicates x and y dash. What is the value of y dash taken? Shashwat, I cannot understand your question. Y dash means what? Actually, y dash means your y dash. In the previous class, I defined y dash is change of origin. Okay. So this means y minus y bar, y dash is y minus y bar. I cannot understand your question. Please, can you write more elaborately? Y dash, y dash, can you mean y by y dash is y minus y bar, which I defined in my previous class? Is it or not? Oh, okay, mean of y. Okay, mean of y. Sorry. Mean of y, I forgot to write this mean of y. So I think you can sum up this by divided by 2. Okay, y mean of y is, you can check mean of y, nothing but a 710. Okay, you can check this. Actually, I did the outline of this calculation, but for detailed calculation, this is your homework. Okay, please do it yourself in your. Okay, this is your homework, and this is just the outline of the calculation. Okay, y bar is 710. Can you check this thing? I think 710. Okay, Shashwat. So, have you any question? Anybody have you any question? Please tell me. Go to the next property. Before go to the next property, please tell me, have you any question or query? No problem. If it is so simple, I will answer it. Okay. So, okay, so Shruti, thank you. So, R is either 1 or plus 1 means X and Y are perfectly linearly associated. If it is R equal to 1 or minus 1, this means perfectly. Otherwise, if R goes to 1 or minus 1, that means it is take either above 0.9, that is 0.92 or 95 or 96, etc., or minus 0.91. This means very close to 1 or minus 1. This means X and Y are strongly correlated. Okay. If R lies between, that means actually I give you the range. Actually, if R lies between mod R, okay, lies between 0.92 mod R less than 1, then X and Y is strongly linearly associated. If it lies between 0.8 to 0.9, this means X and Y are fairly good. Correlation between X and Y are fairly good. Okay. And 0 point, okay, you can little fix only 0.7 to 0.9. Okay. You can treat it as a fairly good. When 0.5 to mod are less than 0.6, moderated relationship. So, and less than 0.5 to I think you can, okay, uh, 0.5 to 1, it is a linearly strongly this classified as strongly. A little bit I want to change the range little bit. Okay, sorry, these are the all are thumb rule actually. This is 0.9 if R lies between 0.9 to 1 or minus 1 to 0.9. Okay, you can take a equality sign. I think it is strictly less than sign. Here also, this is a strictly less than. This classified as strong correlation. Okay. Now, if 0.6 to 0.9 or minus 0.9 to minus 0.6, this is classified as good. Zero point 0.4 to 0.6 or zero point 0.6 to 0.4 minus 0.4, this is moderated. Okay, and if are less than 0.4 or greater than minus 0.4, poor correlation. Some people can break this range also. This good divided into two parts. If 0.8 to 0.9 or 0. minus 0.9 to minus 0.8, this takes as fairly good, and remaining portion, that means 0.6 are less than 0.8 or minus 0.8 less than minus 0.6, this classifies as good. So some people classify this is good, or you can break this two part, it is fairly good or good. I think it is you can use this. This is better than this. So this is moderated and this classified as 4. Okay, these are the uh, thumb rule. You can consider these are the thumb rule. So in the way we can classify the association strength of the association between two variables x and y. Now we can prove that the correlation between x and y lies between minus 1 to 1. Okay. Suppose we are given 10 pairs of values xi, yi, I from 1 to n of the variable x and y. Sorry. Then r equal to 1 by n sum over I from 1 to n xi minus x bar yi minus y bar divided by sx sy, which are the SDs of x and y respectively. Okay, so we can write this is again as xi minus x bar by capital Sx yi minus y bar by capital Sy, where xi minus x bar by capital Sx denoted by small pi and this is denoted by small qi. Where pi equal to xi minus x bar by capital Sx, qi equal to yi minus y bar by capital Sy, where I from 1 to small. Now, summation I from 1 to n pi qi, which is equal to ni. You can check that summation pi square, this is nothing but a small n, because summation pi square I from 1 to small n is equal to sum over xi minus x bar whole square by sx square, and sum over xi minus x bar whole square is n into sx square. Therefore, summation I from 1 to n pi square equal to n. Okay. And summation I from 1 to n qi square, which is again small n. Now, we know sum of squares always greater than equal to 0. Therefore, sum of I from 1 to n pi plus qi whole square, which is greater than equal to 0, because squares of real quantities are non-negative. Or if you break this left hand side, then summation I from 1 to n pi square is nothing but a small n. Summation I from 1 to n pi square is again small n, and this is 2 into summation I from 1 to n pi into qi, which is equal to n into r. So this is nr greater than equal to 0, or 1 plus r, this is again greater than equal to 0. This implies r greater than equal to minus 1. Again, sum over I from 1 to n pi minus qi whole square is again greater than equal to 0. Similarly, we get this thing is n plus n minus 2n r greater than equal to 0, or r less than equal to 1. I denote this by 2. So from 1 and 2, we get r lies between minus 1 to plus 1. We see that r equal to minus 1 when we know sum of square equal to 0 means each of the components should be 0. So this means pi plus qi whole square equal to 0 for all I, or pi equal to, sorry, qi equal to qi equal to minus pi for all I, or yi, qi means yi minus y bar by sy. So I could replace this value, and similarly if I replace the value pi by xi minus x bar by sx, then I get it is equal to yi equal to y bar minus sy by sx, xi minus x bar for all I from 1 to small n. Here all pairs of values of x and y lie within lie on a straight line y equal to y bar by sy by sx x minus x bar. In other words, x and y are exactly linearly related, and the slope of the line being negative. Similarly, again, r equal to 1 when for each I pi minus qi whole square equal to 0, and after substituting the value of pi qi, we get yi equal to y bar plus sy sx into xi minus x bar. So we get the same conclusion. So all the pairs of values satisfy the equation y equal to y bar plus sy by sx x minus x bar, that is x and y are exactly linearly related. The slope of the line being positive. We can prove this property number 4, that is r lies between -1 to 1 alternative way, that is we can use Cauchy-Schwarz inequality, CS inequality. I think do you know the CS inequality or not? Please tell me. Can you heard the name CS inequality? Please tell me. No problem. If not, then I will state first, then prove this property. Okay, thank you, Shashwata. So just I state this CS inequality. If A1, A2, AN and B1, B2, BN be two sets of real numbers, then summation I from 1 to n ai square summation I from 1 to n bi square, this is greater than equal to sum of ai into bi whole square. Okay, so this is a CS inequality. And according to the CS inequality, equality holds if and only if AI proportional to BI. So if I take AI equal to PI and BI equal to QI, then we get sum over PI square. I already defined PI. PI is xi minus x bar. This is our PI. This is our PI. Xi minus x bar by Sx. Qi is yi minus y bar by Sy. So if I take AI equal to Pi and Bi equal to Qi, then the sum of I from 1 to n Pi square, sum of I from 1 to n Qi square, this is greater than equal to sum of I from 1 to n Pi Qi whole square. Okay, so this implies summation Pi square means this is equal to n. Similarly, summation Qi square, this is again n. So this is n square. Left hand side is n square and right hand side is n square into r square. So this implies r square less than equal to 1. Hence, r lies between -1 to +1. And equality hold according to CS inequality when AI proportional to BI. I can write this BI proportional to AI, that is K into AI, where K is a proportional constant. So we can write this as yi minus y bar by, this is this is Qy according to CS inequalities. It should be Qy equal to K into Pi for all I from 1 to n. So this means yi, which is equal to y bar plus k into sy sx xi minus x bar. So here also you see that this is, say, the equality holds when x and y are linearly related. And if you consider r equal to -1, then you get k equal to -1. And when you take r equal to 1, then you get k equal to 1. So we get same contributions. So you can also prove this inequality via CS inequality. Okay. So, Dr. Prabhu, have you any queries? Shayok, Sashoto, please tell me. Swarnabho, can I rub this question? Please tell me. Can I rub this question? Okay. So when you finish it, please tell me. I think I can rub the left hand side. Okay. I can rub this portion on left hand side. I think you can finish this portion. Okay. sorry, correlation of computation of correlation coefficient from group. Suppose we have suppose we are given n pairs of values of variables x and y in a bivariate frequency table with k classes for x and l classes for y. Let Fij be the frequency of ijth cell where I from 1 to k, j from 1 to l. If xi and yj denote respectively the class marks of ith class of x and jth class of y. Then we already defined this formula, that is Rxy is equal to, for group frequency theta, 1 by n. N is the total number of frequency, sum over I, sum over j, xi minus x bar, yi minus yj minus y bar into Fij by root over 1 by n, sum over I from 1 to small, I from 1 to k, j from 1 to l, xi minus x bar whole square fi naught. Fi naught is a marginal frequency of ith class of x, and 1 by n sum over j from 1 to l, yi minus yj minus y bar whole square f naught j. F naught j is a j marginal frequency of jth class of y, where fi naught, this is equal to sum over j fij, f naught j, which is equal to sum over fij I x bar, this is equal to 1 by n sum over I xi minus xi into fi naught y bar, which is equal to 1 by n sum over j yj f naught j. Now, for reduce the labor of the computation or easier of computation, we make changes of base and skin for both x and y. Let u equal to x minus a by c, y equal to y minus b by d, where AB are class marks near the middle of the range of ranges of x and y, and C dr widths of class intervals of for x and y respectively. Since C and D are of the same sign, Rxy equal to RUV, and RUV can be written as 1 by n sum over Ij Ui minus U bar Vj minus V bar Fij by root over 1 by n sum over I Ui minus U bar whole square Fi naught into 1 by n sum over j Vj minus V bar whole square F naught j. Now we can simplify this formula. We already discussed this thing in our previous class. Sum over 1 by n sum over Ij Ui Uj Fij minus U bar V bar. Similarly, we can simplify this as sum over I Ui square Fij, actually Fi naught minus U bar whole square. Similarly, we write this as 1 by n sum over j Vj square F naught j minus V bar whole square. Now, calculation of UI Ej Fij is laborious, and it is done in two stages. Stage 1, we can find for different fixed values of j, sum over u I Fij equal to capital Uj, and then get via Vj Uj, which equal to summation I summation j ui Vj Fij. So this is a stage 1, and this portion is, I think I can break this to portion. This is the stage 2. Okay, then get this, which is the, equal to this. So this is stage 2. So suppose consider the problem. The problem states as find the correlation coefficient between marks in English and marks in mathematics. From the following bivariate frequency distribution. This is a first class of x, 15 to 20, similarly 20 to 25, 25 to 30, 30 to 35, 35 to 40, and this is total y 0 to 20, 20 to 40, 40 to 60, 60 to 80, 80 to 100, and this is total. So for this class, F11 is 4. It's better to write differently, that is 4. This is 0, this is 2, and these are the 0 frequency, okay? So 6 is, this is this represent F01. This is F11. This is F12. F13 is 0, okay? This 0, this 0. 6, 5, 3, 2, 3, 1, sorry. 1. And this total is 15. 9, 4, 2, 1. Empty place means 0 frequency. Okay. So 16. 7, 4, 1, 12 total frequency. And this is 1. And 10, this represent F1 naught. Similarly, 2, 3 is F2 naught. 12 is F3 naught. So I think it is a, this is my mistake. It should be 1 here. And this is 1. Okay. So first, you prepare the following table. I give you the hint. XI, the class marks. This is I need a big table. Okay. So I need to erase this portion first. So class mark XI is the mid value. Okay. This is the mid value. YI is a class marks of Y. Please write this thing. And Here is ui, this is ui, and this is vi. Okay, so 0 plus marks is nothing but a mid value, that is 0 plus 20, this is 10, this is 30, 50, 70, 90. And the class mark of xi, that is 15 plus 20, that is 17.5, 22.5, 27.5, 32.5, 30, 17.5, 22.5, 27.5, 32.5, then 37.5. Okay. F naught j, Vj F naught j, Vj square F naught j, Uj, Vj, Uj. So this is minus 2, Vi is minus 2. So Vi means Vi xi minus a, that is the mean value, and mid value, that is ui mid value. Vi equal to mid value is 50. So we should take xi minus 50 divided by width. Width is 10. Sorry, width is 20. So 10 minus 50, that is minus 40, divided by 20, that is 2. Similarly, this is minus 1, 0, 1, 2. Similarly, you can compute this is the mid value, and width is 5. So we get this value minus 2, minus 1, 0, 1, 2. So please do it yourself, this portion. Similarly, you can do this portion also. Fi naught, ui, fi naught, ui square, fi naught, then vi, and last column is, last row is ui vi. Please do this thing yourself, okay? And you, for whether your computation is correct or not, you need to check this this column and this column. So the last entry of this column, the last entry of this column should be last entry of this column. So okay, I do it yourself. I do it, okay? No problem. So please check my calculation, okay, whether it is correct or not. So this is 4, 2, 6, 5, 3, 1, 9, 4, 2, 1, okay? Just I fill the frequencies. 7 4 1 1. Okay, so now fi naught, it should be 10 23 12 4 1. And look at this column, this is 6, then this is 15, then this is 16, this is 12, and last one is 1. Okay, and total frequency is 50. And this is our small. UI fi naught, UI fi naught is minus 2 into 10. This is minus 20, minus 23. This is 0. This is 4. 1 into 4. Then 2 into 1. This is 2. And sum of this part, that is minus 37. Because minus 20 minus 23, that is minus 43, plus 6, that is minus 37. This is minus 37. Okay, this is minus 37. When UI squared fi naught, this is 40 23 0 4 4, and if you add this column, this gives you 71. Okay, vi is same as UI. I forgot to define this vi. Okay, so vi is, to look at the formula, vi equal to sum over j vj, small vj, fij. Okay, this is vi. And ui, I already mentioned this thing, sum over I ui fij. This is uj. Okay. Okay, so capital uj, capital vi. So capital vi, this is, if you do this thing, okay, this is minus 14, minus 2, 3, 0, 0. So I write this column here, vi, minus 14, minus 2, 3, 0, 0. And the sum of this portion is minus 30. It's a sum. Okay, this entry. Similarly, so it is capital Vi. Sorry, is change the notation. This is capital Vi, and UI capital Vi. This is 28, 2, 0, 0, 0. This gives, the sum is 30. Okay. Actually, I use these portions, these three last 5 rows, for checking the computation, whether this computation is correct or not. Okay, so similarly you can do this thing, minus 12, minus 15, 0, 12, 2, minus 30. Now you see that the minus 13 this here and here. So this means now up to that the calculation is correct. Now this is 24, 15, 0, 12, 4, 55. And U capital Uj minus 10, minus 16, minus 5, minus 6, 0, minus 37. And here you see that minus 37 is same as this. So after that the calculation is correct. 20, 16, 0, minus 6, 0, 30. So this 30 and this 30. So this means the calculation is correct. Now just put the values in the formula, we get the result. Okay, so RUV this is equal to put this value, then in the formula we get this value. Please check. And since the sign of UV and XV, sign of RXY and RUV are same, so this from this we can conclude the correlation coefficient of XY is nothing but a 0.43. So please tell me, have you any queries regarding this computation? You take your time to finish this calculation, okay, in your home. So this is your homework. So if you have a doubt, please tell me. Okay. So today now we want to discuss the limitation of correlation coefficient. This is the last portion which is I'm going to discuss of today class. Okay. After that, I end this class. After this discussion, I end this class. Okay. In the next day, we will discuss regression analysis. So please tell me, have you any queries? Shashato or Prabhu, please tell me. Can I wrap this portion? Tell me. Can I wrap this portion? Are you hearing me? Please tell me yes or no. Are you hearing me? Prabhu, Shashato, Sumon, Shayok, Arnav, please tell me. Okay, Shashato. Thank you. Okay. Just I am asking you, can I already see your response, okay? but I am still waiting for other people. Okay, Shashwat. So limitation of correlation coefficient. Correlation coefficient is a measure of linear association only. Hence, a low value of the correlation coefficient does not rule out the possibility that the variable may be related in some other way. For instance, the following data on the variables x and y x is equal to -3, -2, -1, 0, 1, 2, 3, y equal to 6, 1, -2, -3, -2, 1, 6. Here we see that summation xi equal to 0, this implies x bar equal to 0 and sum of xi yi, this is 0. Hence, covariance of x comma y should be 0. Therefore, Rxy equal to 0. But here, y equal to x square minus 3. That is a perfect nonlinear relationship exists between the variables. Thus, correlation coefficient totally fails to measure the strength of the relationship between variables when they are not linearly related. It is therefore suggested that before calculating correlation coefficient, one should check if the variables are linearly related or not. This can easily be done by drawing a scatter diagram. Actually, I mean to say correlation coefficient exists means x and y are linearly related. If correlation coefficient 0 or very small, this does not imply x and y are, are not associated. We can only say that there is a poor correlation, poor linear association between x and y, or there is no linear association between x and y. That's all. Not more than that. Drawing a scatter diagram. Again, correlation coefficient may give quite misleading result if the data do not come from the same source. If the data arises from different source, different sources, they may give a significant value of correlation coefficient R. Although the variables may appear to be uncorrelated. This is a new point, okay? You can understand if you data come from Sashato, data come from different sources. I draw the I will draw the scatter diagram, then you can understand this thing. Okay, Shashwat, this is a new point. First point is correlation coefficient used only when there is a linear association. Actually, correlation coefficient 0 does the first point. The limitation is it can measure only there is a linear association or not. That is, if correlation coefficient is 0, you cannot say that there is x and y is independent. You can only say that x and y are not linearly related. That much. And second point is if data come from the different sources, and if you gather all the data, then you can sometimes you can get a misleading result because data came from the different sources, so it is automatically independent. Okay, so although the variable may appear, this is the second point. Okay, may appear to be uncorrelated when the data from different sources are treated separately. Treated separately. The following figure explains the situation. This is means zero correlation. This comes from one source. Again, this is a zero correlation, comes from second source, third source, and so on. But if you look at the whole data, you can see that there is a positive correlation coefficient between x and y. But in reality, this is not true. These are independent. Okay, that's why this is called misleading correlation coefficient or misleading result. Third point, it is to be noted that a high correlation between two variables does not necessarily mean that the variables are causally related. We may find it is noted that high correlation between two variables does not necessarily mean that the variables are causally related. Okay, we may find this is CAUSALLY. We may find high correlation only because both variables depend on a third variable. We have to be careful about it, particularly when we deal with time series data. Two series of values for two variables recorded for the same point same points of time may give a high positive correlation when they have similar type of trend and they high negative correlation when they have similar type of trend. They have, it's not similar, sorry, for positive similar, for negative correlation when they have opposite type of trend. Though in reality they are not causally related, For instance, a high positive correlation may be found between number of school going children and production of motor car in India during last 15 years. See that these variables are not related, but but we can find this, but numerically we get that there is a for actually uh, production of motor car does not do not have any impact on number of school going children, whether it's increase or decrease. But we see that there is a positive correlation between these two variables. So such type of correlation between two time series is called nonsense correlation. It is advised or it is advisable that before computing correlation coefficient, one should satisfy oneself that one variable is the cause of the other. Please keep this point in your mind. Before computing correlation coefficient, you should check that whether one variable is the cause of the other. So these are the limitation of correlation coefficient. I close the or end the class today, and in my next class, which will be held on Sunday at same time 6 p.m. coming Sunday same time 6 p.m. and we will discuss linear regression. So please tell me, have you any queries or question before ending the stream? Okay, I think the date is 22nd. Okay, maybe 22nd. So please tell me, have you any queries or question? Otherwise, I end this stream. So please tell me, can I end this stream? Have you any queries? So then please tell me, I will expand you. Yes, you can ask. Phone or WhatsApp, you can, or mail me. Okay, thank you. Thank you, Shashwat. So thank you everybody who are watching this video. Stay with us. Thank you.